Okay, Assalamualaikum and good morning. Yeah, how are you? I hope you are well, yeah, ready to learn about quantum numbers. Yeah. Okay, let's proceed with quantum mechanics, particularly quantum numbers. Yeah, for today. Okay, now let's have a look at the first quantum number. The first quantum number is known as the principal quantum number. Yeah, the principal quantum number, the symbol for it is n. N is also known as shell. I think you are very used, yeah, to the notation of shell, yeah, at school, which is also the energy level, yeah, of the electrons in atoms. And N can start with number one, two, three, and so on. That means it must be a whole number. The second quantum number is angular momentum quantum number. Okay, shell is very big, right? Shell is very big, so subshell is slightly smaller. Okay, in the shells there are few subshells. So what are the numbers for subshell? L, yeah, in italic, starts with 0 until n minus 1. Okay, what are quantum numbers actually? Yeah, quantum numbers are just like postcode. Yeah, postcode. Okay, for example, the postcode here is 31600, where 3 here, who knows? 3 represents the state, perak, right? So if your mother sends your parcel, the post guy, the postman will look at the postcode first so that he or she knows which is the state or what is the state that that is necessary or not necessary. What is the state? Yeah, what is the state for the parcel to be sent to? Now, so 3 means perak. But knowing the state, is it enough? State only? It's not enough because the state is very big. So it's the same thing with shell. Shell is very big. So we need to know, yeah, the smaller area of it. Yeah, we specify further. So the subshell starts with 0 until n minus 1. Just like the postcode here, 3 refers to the state and 1 refers to the district, ya, daerah dia. So now, if n equals to 1, in energy level number 1, what is or are the L values? Angular momentum quantum number. Remember, L starts with 0. So we always have 0 for whichever energy level. And then until n minus 1. What is our n in this case? Our n is 1. Therefore, 1 minus 1 is just 0. Same number as the one before. Therefore, we only have one L value when n equals to 1, which is 0. Are we okay? Okay, now let's have a look at the second energy level. Okay, in energy level number 2, how many L values do we have? Remember, L starts with 0. Yeah, until n minus 1. What is n in this case? 2. 2 minus 1 is just 1. Therefore, the second number, the second L value for 2 is 1. So how many do we have for energy level number 2? Yes, two L values that are 0 and 1. Now, can we have a look at one more example? Okay, in energy level number 3, yeah, energy level number 3, L starts with 0, correct, until n minus 1. What is the n in this case? 3, right? So 3 minus 1 is 2. Pandai. So 0, what do we have between 0 and 2? 1. Pandai. So how many L values do we have for 3? Yes, 3 values. 0, 1, and 2. Okay, what does 0 mean? 0 means the subshell is S. Whenever you see 0, that means it has S subshell. 1 means P. 0 here means, what is it again? S. 1 means P. And 2 means D. If you have 3, yes, it means F. If you have 4, G, and so on. It follows alphabetical order. Alright? Okay, now, let's have a look at the magnetic quantum number, M. Now, how do we get, or what are the M numbers? M numbers starts with negative L until positive L. Now, in this case, look at the 0 here. What are or is the M values? Okay, 0 starts with negative. Remember, yeah? This is the L value. So, from negative 0 until positive 0, it's just 0, right? Okay. And for number 2, we have 0 again here. That means from negative 0 to positive 0 is also 0. And for 1 here, the number, the the M value starts with negative L. What's the L number? 1. So there are negative 1, 0 until positive 1. Right? Okay. What about 0 here? Negative 0 to positive 0 is just 0, just like before. And what about 1 here? Correct. Negative 1, 0, and positive 1. What about D? Okay, can I have it here? Okay, D is the L value. That means the M starts with negative 2 until positive 2. What are the numbers you have in between? Negative 1, 0, positive 1, and positive 2. Okay, now, what does M represent? M actually describes the orientation. Remember, go back to the definition of orbitals. Orbitals means the three-dimensional region around the nucleus where there is high probability of finding an electron. Right? Okay, now, orbitals in this case, are the areas in which we can find these electrons. Right? Okay, so now, number of orbitals. How do we know the number? Look at the numbers, the M numbers that we have here. Okay, how many number for this one? It's just 0, right? That means the number of orbital is just 1. How many orbital here? One number only, right? Therefore, the number of orbital is 1. Okay, how many orbitals in p subshell? How many numbers? How many orientation? 3. Therefore, there are 3 orbitals in the p subshell. What about d subshell? How many orbitals do we have? 1, 2, 3, 4, 5. Therefore, altogether, 5 orbitals. Right. Who can tell me one orbital can accommodate how many electrons? Right. One orbital can accommodate a maximum of only 2 electrons. Yeah, for example here, this s orbital. Yeah, there's only one orbital here. One orbital has 2 electrons. Can accommodate, yeah, not necessarily it has 2 electrons. It can accommodate 2 electrons. So the first one will move in clockwise manner, positive half, and the second one rotate or move in anti-clockwise direction. Therefore, the numbers that signify the rotation is negative half. Right? Same thing here. For this orbital, maybe there are 2 electrons. One positive half and the other one is negative half. Alright? Okay, so if I ask you, how many electrons can the d subshell accommodate? Okay, there are 5 orbitals, right? Therefore, maximum, it can accommodate 5 times 2 electrons, and that equals to 10. Alright? Okay, now let's move on to question 12c. It says, give one set of possible quantum numbers for n electron in 3s, 4p, and 3d orbitals. I'm just going to show you one example. Okay, let's have a look at 3s first. Now, from the given information, do we know the n? Yes, the energy level is 3. Do we know the L value? Remember, for S, the code is 0. Therefore, L is 0 here. And what about M? When L is 0, remember M starts with negative L to positive L. That means M is also 0. And the spin quantum number, because it asks for one set of possible quantum numbers for one electron, so the answer is either positive half or negative half. Choose either one. Right? And I think you can complete the other two. Okay, and then let's have a look at 15b. Which of the following quantum numbers are allowed? Explain. So I'm using 15b as example. Is this set of quantum numbers allowed? Okay, let's check. How do you check? Of course, you have to find out the numbers. Okay, when n is 3, okay, what are the L possible values? Yes, 0, 1, and 2. So is 1 correct? Yes. 1